Hello everyone. In this video, we are going to learn how to debug ARM7 assembly programs in Keil. One important thing to remember is that the first error is usually the real error. Many of the remaining errors are simply consequences of that first mistake. Now, let's begin. Our initial program looks like this. Now, let's build the project. The first few errors are unknown opcode demo, unknown opcode entry, and a label was found which is in no area. Notice that we are not going to jump to entry immediately. We always start with the first error. Let's locate the line 1. The assembler says unknown opcode demo. At first glance, this looks strange. Demo isn't supposed to be an instruction, it's supposed to be the name of the area. So, why is assembler treating demo as an opcode? To understand this, we need to know how ARM assembler reads a line. Every line is divided into fields. The first field is the label field. The second field contains the instruction or assembler directive. The remaining fields contain operands. Assembler directives like area, entry, and end should begin after whitespace. However, our code starts like this. That is, area starts in the first column. So, our ARM assembler assumes it's a label. It then moves to the next word, demo. Now the assembler expects an instruction or assembler directive. Instead, it finds demo. There is no ARM instruction or assembler directive called demo, so it reports unknown opcode demo. The problem is not demo. The real problem is that area was interpreted as a label instead of a directive. To fix this, indent the area directive. Now let's rebuild. Now the first error changes. Unexpected characters at end of line. Notice something important. The previous errors, unknown opcode demo, a label was found which was in no area, have disappeared. We didn't fix every error, we only fixed one line. Once ARM assembler recognized area as a directive, it was able to continue passing the file and reveal the next actual problem. Unexpected characters at end of line. The first line now looks like this. The assembler now correctly identifies area. It starts reading its parameters. The syntax of area is area followed by area name, comma, code, comma, read only. Notice the commas. The assembler reads area, then demo. After reading demo, it expects a comma. Instead, it immediately encounters code. Now it no longer understands the remaining text. That's why it reports unexpected characters at end of line. Separate the parameters using commas. Now let's build the project again. Now the first error becomes unknown opcode entry. Again, this demonstrates an important point. The assembler can now understand the area directive, so it moves further into the program and finds the next mistake. Locate the line of this particular error. That is over here. Let's understand what this means. At this point, ARM assembler is reading the instruction field of the line. It expects one of the three things: a valid ARM instruction, a valid assembler directive, or a macro name. The word entry matches none of these. The assembler does know a directive named entry, not entry. A single extra character is enough to make it an unknown directive. So now remove the extra character, and if you build the project again, that error has disappeared. Now the next error becomes bad register name symbol, expected integer register. Let's locate the offending line, LDR R16, array 1. The assembler says bad register name. Why? Because ARM7 has 16 registers. They are R0 through R15. There is no register called R16. Since the assembler knows the valid register names, it immediately rejects this instruction. Replace R16 with the valid register. Since we want R0 to point to our array, we will write LDR R0, array 1. And now when we rebuild, you can see that error has disappeared. Notice that we still haven't added the equal sign. That isn't causing an assembler error. We'll discuss why later when we cover logical and runtime issues. For now, our goal is simply to remove the current assembler error. The next error is missing comma. The move instruction requires two operands, the destination register and the source operand. These two operands must be separated by a comma. Without a comma, like this, it looks like one invalid operand to the assembler. Therefore, it reports missing comma. Now, insert the comma here and rebuild the project, and that error has disappeared. At this point, we have fixed 5 different assembler errors. Notice how the error list became shorter after every rebuild. In the next part, we'll continue debugging the remaining errors and finally transition from syntax debugging to runtime debugging.